Robot Room Cleaner. The room is a grid of open and blocked cells. You control a robot that can only use 4 APIs: clean the current cell, turn left, turn right, and move forward. Move returns true if the robot moved and false if blocked. Your goal is to clean every accessible cell. You do not know the room layout or where you start. Move returns true if the robot moved to the next cell, and false if it couldn't, for example when there's a wall or blocked cell. Here we have an open cell, so move succeeds. We must clean every accessible cell in an unknown room using only move, turn left, turn right, and clean. We don't know the grid or our starting position. We explore the room like a maze, go as far as we can in one direction, then come back and try another. We remember which cells we've cleaned. When we're done exploring from a cell, we walk the robot back so we can try the other directions. That's depth-first search with backtracking. We use DFS with backtracking. We track visited cells in relative coordinates. We try a fixed order of directions. After exploring a direction we backtrack so we can try the next one. We start at the top left. We're about to clean this cell and add it to visited. We called move, and got false, up is out of bounds. So we'll try the next direction, turn right and move to the next cell, then clean and recurse. At every new cell we do the same, try up first, then right, down, left. When DFS finishes, the robot would backtrack all the way back to its starting cell. Time and space are both O of the number of accessible cells. We clean each cell once, and the visited set stores each cell we've been to. This is the graph visit all template, mark state visited, then for each neighbor, if not visited, recurse. When the recursive call returns, we backtrack and try the next neighbor. Robot Room Cleaner uses this same structure. Main entry, clean room receives the robot. Leetcode calls this. We track visited cells in relative coordinates, start with an empty set. Start DFS from cell 0, 0, facing up, north. Define DFS with current cell row, col, and which way we're facing. Clean the current cell. Mark this cell as visited so we don't clean it again. Try each of the 4 directions in order. Turn to face direction D and compute the neighbor cell. If that cell isn't visited and move succeeds, we recurse. After a successful move we're still facing direction D, so new_facing equals D. Recurse to explore from the new cell. After returning, backtrack, turn around, move back, turn around. Turn right so we're aligned for the next direction in the loop. In each pass we use the facing we're passed in. We compute how many turn rights we need to face direction D, that's D minus facing, mod 4. After those turns we're facing D. If move succeeds, we're at the new cell still facing D, so new_facing is D. If move fails, we're still at the same cell facing D, we turn right once to align with the next direction in the loop.